This is Brendan Cusack with Cusack Prep, and this is going to be part 2 of our series on complex numbers for the SAT or the ACT. Now, in part 1, we went over kind of the basics of complex numbers, how to see that pattern between I to the first, I to the second, and gave you a technique to really go all the way up to I to the 355th power. Now, what we're going to do is we're going to teach you how to multiply complex numbers and FOIL complex numbers, so anything dealing with that. So just a quick reminder that I to the first is equal to I squared is negative 1, I cubed is negative I, and I to the fourth is 1. If you're just coming across this video, there is another video on our channel that goes over why that is and how you can extrapolate that out further. But for now, we're just going to deal with how to multiply these things. On the SAT or ACT, you always want to leave complex numbers in what you call standard form. And what standard form is it's A plus BI. So let me write that out really quick. So standard form, not sure I like this color of orange too much, is A plus BI. A couple of things to notice really quick. There is no I squared, there is no I cubed, so you want to make sure you deal with that appropriately, and that's why we use all these numbers over here on the left side. So now let's just go ahead and get into it. So let's say I wanted to take this value right here and multiply it. One thing with complex numbers is they're actually incredibly similar to anything you're going to do with x, just with that exception of changing from I squared to negative 1 at the end. So let's go ahead and take this, and if I were to distribute, and that's what we do when we have multiplication going into parentheses, this to each of these two terms, we would find that 2i times 4 is 8i. We just multiply the two constant values, the 2 and the 4, and we multiply the I value by it. There's nothing there, so it's just I. And then if we do 2i times negative 3i, 2 times 3 is negative 6, and I times I is I squared. Just like x times x is x squared, or 3 times 3 is 3 squared, I times I is I squared. Now, the only problem with this so far is that it's not in this standard form of A plus BI. So how do we get it there? Well, if we recall, I squared is equal to negative 1. So what I'm going to do is I'm going to take this I squared value, and I'm just going to simply replace it with negative 1. I can do that because the two are equivalent to each other. Negative 6 times negative 1 is going to give you 6, so this would then end up equaling 8i plus 6. And put in standard form, generally you put the constant number, the one that is totally alone, by itself. So when we do that, we put that in the front. So we would end up with 6 plus 8i as our final answer. Going on to the next problem. Very similar type. Maybe pause the video, try this on your own before you follow along. So we're going to multiply 3i times 2i. When we do that, we know that 3 times 2 is 6, and I times I is going to give us I squared. And then we multiply 3i by negative 4. Negative 4 times 3 is 12, and we're just left with an I at the end. Now, 6i squared, just like we did last time, is going to be negative 1. 6 times negative 1 minus 12i. And 6 times negative 1 is just negative 6. So this would be our completed problem in standard form at the end. Now, sometimes we have to FOIL complex numbers on these standardized tests. So we're going to go ahead and do that. So let's say I go ahead and FOIL this. 3 times 4 is 12. 3 times 5i is plus 15i. Negative 2i times 4 is going to be negative 8i. And negative 2i times positive 5i is going to be negative 10i squared. Now, we can first start by combining some of the similar terms. So 12, 15i minus 8i is going to be plus 7i. So I'm just taking these two terms and combining them into one. And then I squared is negative 1. So I'm going to go ahead and just put a negative 1 in the place of I squared, again, because we're trying to get it to that standard form. 10 times negative 1 is going to be positive 10. If I take 12 and I add 10 to it, because just subtracting negative 10 is the same thing, this is going to end up giving me a 22 plus 7i. And that's how you do that. All right, now what I'm going to do is I'm going to go ahead and leave this one for you and this one for you to try to see if you can get it. So pause the video, give it a shot. Okay, now let's see if we can do this. So that times that times that. It's going to be 30i squared minus 18i. Again, we take the I squared, we turn it into negative 1. And this becomes negative 30 minus 18i. FOIL this one. 10 plus 20i plus 6i plus 12i squared. Slide this down a little bit. 12i squared is negative 1. So this term here becomes negative 12. So 10 minus 12 now is going to be negative 2. 20i plus 6i is going to give me plus 26i. Now, these last ones are a little bit tricky, and I always see students make this mistake, so you want to be very careful of it. So I'm going to start with pointing out what that mistake is. If you have 5 minus 2i squared, this is absolutely not equal to 5 squared minus 2i squared. I see students do that all the time. Don't do that. Some teachers call it math jail when you do it. A lot of teachers have different names for it. Don't do that. Just that's not correct. What is correct is when you're squaring something, it means that you are multiplying it by itself. So if we're squaring 5 minus 2i, what that is 5 minus 2i times 5 minus 2i. That's what it is. So what we're going to do is we FOIL. In the process of foiling this, just like the last ones, 5 times 5, 25, minus 10i, minus 10i, plus 4i squared. I'm going to go ahead and do the rest of it up here. 25 minus 4i squared is, or plus 4i squared is 25 minus 4, which is 21, minus 20i. Same thing with this. 2i plus 3 times 2i plus 3. Again, do not just square the two numbers inside. This would give us 4i squared plus 6i plus 6i plus 9. This is negative 4 plus 9. It's going to be 5 plus 12i. And then finally, with this one right here, I minus 4 times I minus 4, I squared minus 4i minus 4i plus 16. I squared is negative 1, plus 16 is 15. So this becomes 15 minus 8i. And that's how we do it. So thanks again for watching. This is multiplying or foiling complex numbers. In the next video, we're going to talk about how you simplify complex numbers when I is in the denominator, and we're also going to talk about something that's called the complex conjugate. So I really hope this video helped a lot. I hope you are starting to see that complex numbers on these big standardized tests really aren't that complex. So if you enjoyed the video, feel free to like and subscribe, and thank you for watching.